In this video, we'll learn how to compute limits algebraically. A typical problem will look something like this. You'll be given a formula for a function, in this case x squared minus 5, and an x value for which to find the limit. So we want the limit as x goes to 4 of x squared minus 5. There's a special class of functions called continuous functions for which computing the limit is easy. If f is a continuous function, then the limit as x goes to a of f of x is simply f of a. In other words, to compute the limit, all you have to do is plug in. The good news is that most nice functions are continuous. Polynomials, exponential and log, roots, and even rational functions, which are fractions where the top and bottom are polynomials. Those are continuous as long as the denominator, the thing on the bottom, is not 0. So going back to our problem, if we want the limit as x goes to 4 of x squared minus 5, well, x squared minus 5 is a polynomial, so all we have to do is plug in. We get 4 squared minus 5, which is 11. Here we have a more complicated looking example. The limit as x goes to 2 of x squared plus x minus 6 over x minus 2. And we think to ourselves, well, that's a rational function, and so that's continuous as long as the bottom isn't 0. So what we do is we try plugging in x equals 2 and see what we get. If we get a 0 on the bottom, then we have to do something else. And in fact, that's exactly what happens in this example. So what do we do? Well, in this case, we're going to try to factor and simplify. The top of this fraction, x squared plus x minus 6, factors as x plus 3 times x minus 2. And then we can divide out the x minus 2 on the top and the bottom, and we just get x plus 3. Now that we've simplified our expression, we can go back and plug in x equals 2, because we won't get a 0 on the bottom anymore. We get 2 plus 3, which equals 5. So the answer to our question is that the limit equals 5.